Checking capacitor, and it's reading good. And then we want to make sure all your connections are good. This transformer's been replaced at one point in time, and they've added this fuse in here to not pop this transformer in the future. If you get a low voltage short, it'll just pop this little car fuse here instead of popping that. So that's a good deal to have in there, so you don't have a costly repair in the future if you have a short on your low voltage. All the connections are tight. And we check our blower motor bearings by seeing how much play you have in the motor, which is pretty good. And now I'm gonna put it in emergency heat mode and test the heat banks, and by the amperage I draw on each heater, I'll know whether they're coming on or not. There's two heaters. This heat sequencer is what turns that on, and they'll turn on one heat bank at a time. Maybe 30 seconds in between each stage, so you don't have a light dimming, because it's pulling a considerable amount of amps. Generally, you'll have a 3-degree swing between first and second stage heat, and you may program in a 5-degree swing. When the first stage comes on and it's cold outside and it goes into defrost mode, it'll kick in the heaters, and you're actually turning back into a air conditioning mode in defrost until you melt the ice. And to compensate for that, it turns the second stage heaters on. The outdoor coil freezes up in heat mode, and it's designed to do that, and it has a sensor on the line that will indicate when it needs to thaw the coil, and it either has a timer or a demand control board on there that will switch your reversing valve, turn the heaters on, and turn off the outdoor condensing fan, and traps the heat and melts the ice off of the coil. And then when that sensor senses that the coil is approximately 50-55 degrees, it'll kick in automatically back to your regular heat cycle.